Okay, so let's look at a division problem involving rational algebraic expressions, fractions with polynomials in them. I have a dividend here. Here's my dividend, and I have a divisor, right? And before I proceed, the first thing I want to do is I want to rewrite both of these in their factored form. When I look at the numerator of my dividend, I can see that there is a common factor of x squared. And when I pull that out, I'm left with an x squared minus 9. Now that turns out is the difference of two squares, so I can factor that further. So I guess I'll build my final dividend right here. It's going to be an x squared, and then I'm going to have an x minus 3, times an x plus 3. That looks fabulous. The divisor then can be factored. In fact, it's a pretty straightforward polynomial. So I just need the factors of positive 3 that are going to give me a sum of negative 4, and they're both going to be negative. So I've got a negative 3 and a negative 1. And I can see at this point that I do have a common factor of x minus 3 in the numerator and denominator of the dividend. So I'm going to go ahead and eliminate that. So let me just take a step here. I'll pull this back up in a minute, but I'm going to write my final form of my dividend. That's going to be x squared times x plus 3, and I'm going to be, that's over x minus 1 divided by. All right, so what are we dividing it by? Let's come back here and take a look at this. My numerator has a common factor of x squared, and when we get that out, we're left with an x squared plus a 2x minus 8, which I am sure can be factored further. In fact, let's go ahead and do that. That's going to be x squared times x. Factors of negative 8 that would give me a sum of positive 2 would be a positive 4 and a negative 2. So that's 4x minus 2x is definitely positive 2. And 4 times negative 2 is negative 8. The divisor there is the difference of two squares. I'm sorry, the denominator of my divisor. Interesting, isn't it? I mean, I have a dividend and I have a divisor, but each one of these, because they're rational algebraic expressions, both have a numerator which can be thought of as a dividend and a denominator. So I'm tripping all over the vocabulary here. If I rewrite that denominator, it would be, in factored form, x plus 4 times x minus 4. And I can see that there is a common factor of x plus 4 that I'm going to eliminate now before I proceed. Now, if I write this as a division problem, right, I'm just going to write everything where it was. And now to divide, right, we're going to multiply by the reciprocal of my divisor. This is the divisor, and we're going to be finding the reciprocal of this when we multiply. So I'm going to go ahead and rewrite x squared times x plus 3 over x minus 1, and I'm going to be multiplying that by x minus 4 over the quantity of x squared times x minus 2. Well, I can see that I have a common factor of x squared. Right, if I go ahead and multiply the numerator times the denominator, right, multiplying, I can see that there is a common factor of x squared. So I'm going to eliminate that. And the other thing I'm going to go ahead and do is, well, you know what, I don't have to multiply these out. I'll leave it in this form. So it looks like my answer is the numerator is x plus 3 times x minus 4, and the denominator is x minus 1 times x minus 2.